a changing climate.
Thank you very much, everybody. So I'm Mike, this is Tom, and I'm going to start things off here first of all. So, you guys want to see? Do you want to stick around? Just read over my shoulder. So I'm going to start this morning on the outline here. I'm going to talk about some of the future climate projections. I am also just going to talk a bit about the pest-host climate interactions and how that creates a bit of, I guess, variability in our predictions. And then Tom's going to talk a bit about the abiotic damage agents, the native pests, and then I'm going to come back up and talk about the non-natives and some of the future directions that we're working in our forest health group. So you guys did have a pretty good introduction this morning about some of the predictions when it comes to temperature. This year, this is the mean annual temperature using some generally agreed upon scenarios. We're looking at 3 to 5 degrees increase by the 2050s. When it comes to precipitation, there's a little bit more variability. As was also mentioned this morning, some areas might get wetter, some areas might get drier. Very difficult to predict this at sort of a local scale, even regionally sometimes. But one of the key pieces that is predicted that the largest decrease is going to be during the summer. So that's not good news when it comes to plant health. Some generalities about climate. Based on some of the predictions, we're expecting winters to be warmer with increased precipitation. Also that the spring and summers are expected to be earlier, but with reduced soil moisture. May have a longer frost-free growing season. And then the other thing is that it's predicted that there's going to be a lot more wild weather out there. So a lot more of these extreme weather events that we seem to be seeing more and more of these days, whether it be droughts, floods, tornadoes, etc. So now moving on into sort of the realm of the forest health and the forest damage agents, and making some of the predictions on what may happen if these scenarios do hold out. I am going to talk, and as well, Tom, sort of in some generalities, because it is hard to pinpoint exactly what is going to happen, but we can make some pretty good guesses. And the other thing I'm going to point out is some of the interactions. It's not just the climate impact on the host or just the climate impact on the pest, but there's sort of this interaction. So kind of some sort of themes that you can look at is first of all, a direct impact of climate on the host, which would be something like drought stress. This, you're looking at a picture that was, I believe it was a 2012. This is up north of Fort McMurray. You can see the browning of the aspen. This is a direct result of the moisture stress. The other example could be a direct impact from the climate onto the pests. So in this case, there was a very large spruce beetle outbreak that took place starting in the 1990s in both the Yukon and in Alaska, in the Kenai Peninsula. And what happened is a series of mild winters and nice warm summers created the spruce beetle, or caused the spruce beetle's life cycle to go from what's typically a 2-year life cycle and switch into a 1-year life cycle. So what that allowed it to do is essentially allowed the population to erupt. And what ended up happening is they had about 1.5 million hectares of an infestation. There's also the example when it's some combining factors and things start to get a little more complex in situations like this. When you do have drought impacting the host and the ability of the tree to grow and to be productive, and then you also have insect defoliators that can do the same thing. Typically, trees can withstand some drought. They can withstand it for a number of years. Eventually, trees may die and so forth. Same idea when it comes to forest tent caterpillar infestations. Eventually, if you have enough defoliation sequentially year after year, it can kill trees, but it does take some time. But what we're seeing now is that when you get these two things working in consort, you get the mortality a lot quicker than you would when they're doing it individually. And so climate can impact both these, obviously the drought, but also the ways that the epidemiology of the forest tent caterpillar. But climate can also have both positive and negative impacts on pest populations, and a good example of that is with something like the spruce budworm. What budworm typically does like in a summer is for it to be warm and to be dry. The little bit of moisture stress on the tree does create some more nitrogen in the needles, less terpenes, that sort of thing. Also more flower production, which budworm just love. So usually when you get those conditions is when you get outbreaks of spruce budworm. But in situations where you get some wild weather events, something like an early spring frost, you get a frost in May where you can see the picture there where all those brand new shoots have frozen up and died. Well, unfortunately, the spruce budworm, they can only eat the shoots that haven't been lignified yet. So if all that complete food source is gone, they can't eat the old needles on the trees. So essentially, they either lose their food source or the spring frost itself killed the beetle or killed the budworm. And you can see an example of this was between 2010 and 2011, what our aerial surveys found as far as the hectares of spruce budworm defoliation. We saw this huge crash, and a large part of this we can attribute to a spring frost. So now I'm going to hand it off to Tom.
Thank you, Walter. Mike. So like Mike mentioned, one of the things that we expect with climate change is that there are going to be more or different abiotic disturbances. We'll see probably a lot more different sort of extreme events like drought, which are quite widespread, or other localized extreme weather events, such as hail or windstorms. So I won't go through them all, but I'll go through a couple. The picture in the background, that's red belt, which is a type of winter desiccation that I think we can probably expect more of in the foothills in the future. But I'll start with drought. So most predictions are that we're going to see a lot of areas during the summer that are going to have some sort of water deficit. Again, this is a picture from near the Richardson fire that we had large areas of redding, poplars and aspen, and this was quite extensive. It was tens of thousands of hectares, and it wasn't just in this area. We were seeing it in quite a few areas in northern Alberta. Again, like Mike showed, you see the scorching of the leaves. That's pretty symptomatic of drought stress or leaf scorch. And we probably expect to see more of those kind of events putting stress on trees. Also, because, like Mike said, the insects and the diseases and the climatic conditions tend to work together in concert, you might see things that happen where you have one stressor of a tree then be affected by another stressor, and you end up with a lot of mortality. So these are pine trees around Fort Chipewyan, and they're heavily infected with dwarf mistletoe. So the dwarf mistletoe is already stressing the trees, and then they get into a situation of water deficit, and you end up with a lot of mortality in those trees as well. This is what it looks like on the ground. So you can see the trees that have turned, most of the trees that have turned red are ones that are heavily infected with dwarf mistletoe. So just the combination of the dwarf mistletoe, reducing the vigor of the trees, and then the drought finished off a lot of these trees. Hail events, we're seeing more of them, I think. So this is S7 planning unit, actually quite close to Lawrence Lake. We're flying over and we're looking at it, and those pine stands in the foreground, they just look kind of off color when we're flying, so we got closer down and took a look. And if you look carefully, I don't know if you can see it from there, it kind of looks like one side of the tree is flattened. So all the branches have been knocked off of one side of the tree. And this is what it looks like from the ground. So you can see these are big trees, and they're just absolutely hammered by the hail. And so these trees are stressed, that's why they're off color. But also, we found mountain pine beetle in these stands. So again, that's kind of working in concert. So the trees are stressed, they're more susceptible to other pests and pathogens. This is by Edson, so this is a regenerating stand. So you can see this stand is absolutely hammered by hail. And we've been to these stands lately, and they're a lot greener than they were in this picture, but there's still a lot of damage, a lot of broken tops, a lot of busted sides, and also a lot of puncture wounds in the bark, which then becomes a vector or a port for different funguses and whatnot to infect these trees. So whether or not these trees will ever be any sort of reachable volume is unlikely. And this was a big hailstorm. This was over 6,000 hectares. And you probably expect to see more wind events. So these are shearing winds. This one was by Calling Lake, so that's Calling Lake in the background there, the town of Calling Lake just to the upper right-hand corner. And these are pretty big trees that are all blown over there, and this is a picture of it from the ground. And you can see my hatchet stuck in one of the trees there. You can see the size of the trees that were blown over there. This is another wind event. That was 2004. This is 2007 near Rock Island Lake. And by the pattern of the trees on the ground, I suspect that this was a tornado that touched down there. So you can see the trees are kind of arranged in a circular pattern. And these are big trees again down there. And the thing about these large areas of blowdown, if you get them, they can be, if there's a lot of spruce or other things, they can be an area where you get populations of spruce beetle become established. They have a hard time attacking healthy trees, but they have an easier time attacking, freshly down trees or trees that are stressed. So you can build up a population, and if, like Mike said, the climate becomes favorable for them, then they're off to the races. So we can also expect with climate change that some of our native damaging agents are probably going to either behave differently or cause more damage or different types of damage. So these are two major defoliators in the northern part of Alberta, forest tent caterpillar and spruce budworm. And most of the literature tends to point to the fact that they expect to have increasing frequency and severity of defoliation by these creatures, which puts extra stress on the trees. We may also see native species that start behaving differently. This is, we had a huge outbreak of Anargia, the aspen two-leaf tire, last year. So this was over hundreds of thousands of hectares, and before, all the literature that I looked at anyway just indicated that this was a minor defoliator, not one that would cause large-scale defoliation like it did last year. Some areas was quite severe. Another thing, if you have a lot of stressed trees on the landscape, there's a lot of secondary insects out there that may become more of a problem. They can't kill trees under normal circumstances, but they can if the trees are stressed by other factors. So these are Ips beetles. This particular one is Ips pini. They're a secondary insect. They don't kill healthy trees for the most part. They attack dead or down or stressed trees. But if their populations get high enough, then they can actually attack healthy trees as well. This is another cousin of the mountain pine beetle. This is the turpentine beetle. So again, not a very good insect at attacking healthy trees, but it will attack stressed trees. So this is a tree that was scorched in the Richardson fire. You can see around the base all those pitch tubes and the resinosis, and that's the beetle getting in there. So inside the Richardson fire, where there's fire skips in areas where you have a lot of scorched trees, we're seeing a lot of turpentine beetle, and that's the kind of areas where the populations can increase. And if the fire didn't kill them, then the beetles will finish them off. So this was a seemingly healthy tree that was by one of the Wood Buffalo Environmental Association plots that we're helping to monitor. And I couldn't see anything wrong with this tree, why it was yellow, except for the fact that it's just loaded with turpentine beetle at the base. So it might have been stressed by another factor, and then the turpentine beetle moved in. But again, it's an indication that these beetles can, in some circumstances, attack fairly healthy trees and may become problematic in the future. Another thing we saw in the last couple of years, because we've had fairly wet springs, is we've had wave years of rusts and needle blights and different kinds of foliar diseases on conifers. This is spruce needle rust. I took this picture up by Conklin last year. We had a huge area affected by this particular pathogen last year. So again, not a tree killer, but it does reduce the vigor of the trees and makes them more susceptible to other things that may affect them. This particular pathogen is one, when I worked in BC, this was considered to be a rather minor pathogen. This is red band needle blight. And after the mountain pine beetle epidemic moved through the central interior of BC, they ended up with huge plantations of young pine But they've also had a lot of years, successive years, where they've had warm, wet springs. And this pest that was kind of a minor thing before has become a major, major problem in the central interior of BC. Not a problem in Alberta historically. You can see here's a rupture in one of the needles. So during the spring, if it's mild and wet, these ruptures, the spores come out through that and they get carried on the moisture to attack new needles, fresh needles on the trees. And a couple of years ago, they were reported at the ATISC in Smoky Lake. So here you see them affecting some high-value trees, a pine and clone bank at ATISC. So hasn't been a problem in Alberta before, may become a problem in the future. It's definitely a problem in this situation because these are such high-value trees and it can cause mortality. So this has subsequently been treated. You can see there's some ATISC people out here in the crowd. And then another native species, native to North America, native to Alberta, but acting a bit like a non-native species because it's in areas where it's never been before, is the mountain pine beetle. So you can see the pitch tube in the background there. And the thing I want you to notice is the latitude. It's north of 60. So when I went to school back in 1997, Prince George was outside the native range of the mountain pine beetle. Now they're established in the Northwest Territories. They're also moving fairly far east, so this is an unsuccessfully attacked tree, but what I want you to see here is we're picking up evidence of these beetles as far east as latitude 111, or longitude. So that's about range 7, so only about 60 kilometers away from the Saskatchewan border. We've actually found them closer to the Saskatchewan border at about range 5, so only about 40 kilometers away from the Saskatchewan border. I don't think they're very well established there yet, but we've detected their presence there for 2 years in a row, so I think we are there. And they're not only increasing their range northward and eastward, also in elevation. These are white bark pine that are killed by mountain pine beetle. This happened before in the 1980s, but this particular epidemic is more persistent in high altitudes. So all indications that climate is no longer a limiting factor to their spread. And we do have other insects and diseases that we expect to be influenced by climate change. And you know, if you got a lot of dead, stressed trees out there, we'll probably see increases in wood borers. Root diseases like armillaria root disease are made worse by drought conditions. And stem cankers, especially cytospora canker, we expect to see a lot more of that in the future as well. And now I'll hand it off to Mike to talk about alien invasive or non-native species.
So some of the invasive species things, Kevin mentioned a little bit this morning, but just to give you guys a few examples of what may happen or some of the, I guess, increased threats we may be facing. This year's picture down in Cypress Hills, you can see fields of tall buttercup. And that is, when you look at this map here, this is a sort of a habitat suitability map I got from Natural Resources Canada. You can see that brown color is suitable habitat for tall buttercup. You can see it is down there in the Cypress Hills. The green indicates the core habitat, so the prime habitat for this species. And you can see this is the current range. But if we use some of the models to predict what the climate would be like towards the end of this century, you can see how the habitat just explodes. So similar example, I guess, when we looked at some of the bird range habitats, how they may be shrinking or growing. This is a similar sort of thing. And not only for plants, but for insects as well. These here are some habitat suitability maps from some work that Jacques Grenier did for gypsy moth. And you can see in a period now, just a small fraction of the province is suitable habitat. There has been trap catches of gypsy moth in pheromone traps that the Canadian Food Inspection Agency has done over the number of years. Very few, but there's been a couple. But they've never established, and that could be probably a result of the current climate. But when you look at what it can be 2041 to 2070, we're looking at almost a third of the province. Tom talked about the white bark pine. Well, this is one of the invasive species that affects white bark pine. It's the white pine blister rust. It also attacks other species. But it's thought too that the range of this pathogen is going to be expanding. And the last example here on the invasive side of things is what you're looking at here is some horticultural material that showed up in Fort McMurray, and it was infested with the pine false webworm. Well, currently, Fort McMurray is not a very suitable place for pine false webworm, and likely they've been introduced there before, and they haven't really survived or got a foothold. But as you can imagine, I mean, the vectors for these types of things will continue, and it's probably not the last time pine false webworm is going to be imported into Fort McMurray. So it's just a matter of time, and over again, these things are going to get introduced into habitats where it is suitable. So you've got to be on the lookout for those. It's one of the reasons why we are kind of involved in some early detection work. We support some of the pheromone trapping work with the Stop Dead group. That's the Society to Prevent Dutch Elm Disease. They have some sort of generalist pheromone lures that we use, and they're set up traps in areas where we expect various types of insects may be importing to, and there's some taxonomists that look into these things. So that's part of the future directions, and that's one of them is sort of that early detection on native species. Some of the other things we're hoping to do in sort of, I guess you could call it sort of climate change adaptation work is one of it is the improved monitoring detection of the abiotic damage agents. So in the past, many years back when I started in the forest health business, aerial surveys consisted of looking for spruce butterworm defoliation, looking for aspen defoliation. Well, now we're trying to delineate these large blowdown events, hail events, drought, those types of things. Get a bit more of a baseline. There's also some work on the genetics side. There's some project proposals to look at some pest and drought resistant tree breeding. Another future direction would be the idea of assisted tree migration, and there is a presentation coming up later today by Dio that's going to get into that in some detail, so I won't elaborate on that one. Another thing we're interested in is the long-term monitoring of forest productivity and pest impacts, but in relation to climate. So some of the work that we're doing is in conjunction with the Canadian Forest Service on a CAPFT project, which is about the climate impacts on the health and productivity of aspen. And there's also going to be a presentation later today that Mike McKaylin's going to be doing on that. So that's the idea of getting some long-term data and trying to figure out how, you know, some of the moisture thresholds and those sorts of things. And we're also interested in expanding this project into other species, spruce, for example. Another thing we're interested in is monitoring non-commercial tree species. Oftentimes, just based on our business, we kind of focus in on the pines and the spruces and so forth, but some of these other trees may be less drought resistant, something like white birch. You'll notice you drive around the city, especially here, and there's very few birch that are still living. Well, they're one of the first ones that'll go in drought situations. So it's kind of the canary in a coal mine there for us. And we're trying to, I guess, culminate this information and use it to sort of support this last point. And it's to sort of, you know, is the system that we're in right now, is it going to be the same in the future? So is our sustainable forestry system on a, you know, similar trajectory that it is now? One could argue that it's probably not. So it's probably pretty important to not sweep these ideas under the rug and kind of be reactionary. I think it's important to use this information and try and get ahead of the curve. So as a poet once said, the times they are changing. That was Bob Dylan. And also, speaking of poetry, you guys are lucky today because you stand among greatness. Tom Hutchison here, please stand up, Tom. He is the one and only forest health poet in Alberta. So what he's done today for you guys is he has written a poem specifically for this event. And this is the first public, I guess, recital of that poem. So take away, Tom.
I don't want to blow my own horn too much either, but if you feel like breaking into spontaneous applause after I finish, I'm not going to stop you. The poem is Climate is Made of Weather. Climate is made of weather, and weather these days, it seems, keeps shifting, changing and shifting, Tokyo drifting between different types of extremes. Maybe there'll be snow in August. We've had winter lightning storms. Whatever will come will strike us quite dumb and go against all the norms. Climate's an aggregate measure, partly of temperature trends, and on average they're rising at a rate quite surprising. What that means? Well, I guess it depends. Maybe this range will be normal. We can expect the unexpected extremes, and changes in ranges as climate changes for forest critters may exceed our dreams. Does anybody have any questions?
What's this spring fact that it's still 10 below at nights in April nothing to do with their pine beetle?
I expect that it'll do nothing to the pine beetle. They're going to do just fine with this. What might have hurt them more was that almost 2 weeks of warm weather that we had in January. We're getting like up to +10 a few days there. You know, the underbark temperature got high enough that they started actually assimilating, bringing in their glycol, and it took them too long to be able to synthesize more when we got back down to that, you know, -40 a week later.
Thank you very much, Tom and Mike. That's a great poem. Our next speaker will be Dio Gracious Ray Rom Geza. He said that we can call him Dio though. He's from the Forest Management Branch